Hi, I'm Shannon Sokochoff. I teach at Argyle School in Edmonton, and I just finished talking to one of my students about some of his questions about quadratics, and I recorded our conversation here on this whiteboard. I'm going to talk you through it too. So here is a little piece of what happened in Math 10C. If you're an Alberta student, you'll know what I mean by Math 10C. Otherwise, just think of it as these, what are the building blocks before you can study quadratics. And this one here is an understanding of what a linear function is, because quadratics often is the last part of that is quadratic function. Sometimes you can think of a quadratic equation, but in the world of linear function, we had things that looked like this: y equals 2x plus 3. And then at the bottom you see what it looked like in general. You probably are familiar with that, and if not, it's something you want to look up on the internet. You want to say, well, what is this y equals mx plus b business? So we did, just to explore that idea, we did a table of values together, and we tried just numbers 0 through 4. Turned out that we thought that 0, 3 was kind of special when we graphed it. I'll come back to that. I have coded it in red. I'll tell you about the red business. On the right-hand side right here, you see where we've substituted in the values of x into the function, into this function up here. And that's the mathematics, the arithmetic that we did to get these numbers. And there's a pattern here of jumping up by 2s. We'll see that in another form in a minute. Then we took all those things and we graphed them. Really a rough graph, to be quite honest. And so the points line up in a straight line. That's kind of important. That's where the word linear comes from, actually. At any given point, you have a consistent slope. At any one of those two, distance between any one of those or pair of those points, you'll have a 1 over and 2 up. Slope is the ratio of rise over run, and that's usually referred to by the variable m. So there's a 2 over 1 makes a slope of 2. So this thing rises 2 for every 1 that it runs. And then I did a larger triangle with a run of 5, and it turns out it has a rise of 10, and 10 over 5 also get me that too. So I have the y-intercept here, which I've coded in red, and notice that that's where x was equal to 0. X equals 0, y equals 3, and that is expressed graphically by a point on the y-axis. In the equation, it's always at this spot where there's a plus b, and the plus b value in this example is plus 3. So also notice that the 2 appears in the equation as the coefficient in front of x, and it also appears as the jumping value when you're going consecutively in a table of values. So we have a slope appearing in a few places and a y-intercept appearing in a few places. So that's a little bit about linear functions. The other building block for when you move into quadratics is what you know about factoring these polynomials from grade 10. And there's an example of how you might have factored. You can see some of my other videos about factoring. Some of your teachers will have had you figuring out what two numbers multiply to 6 and add to 5. Or you may have been taught by someone who does this work. This is what I do, and that's what you'll see in my other videos. Also some algebra tile work there. But this should be some of the things that you remember doing. You might have to look up factoring if that was something that you don't remember doing from grade 10 in order to really do well in quadratics. Okay, so we take this thing which is now just an expression. It's no equal sign there, okay? It's just an expression. And now we take it over here to the world where it becomes a function. And this is the first time in this little lesson that I'm using the f of x, or f evaluated at x. So there's the function we're going to think about. Y is also there as an alternative if you like thinking about y instead. But f of x is saying, I'm going to take a value of x, I'm going to do something to it, and it's going to give me a result which I can graph. Turns out to graph like this, but we'll see that in a second too. So right away, what happens when we do this? We tried some values. We just tried -3 all the way to 1 when we realized we were going off the charts at 112. So then we went backwards and tried -4, -5. So you can just see some of the arithmetic we did there. If you want to pause and take a look at how those negative signs, when they get squared, they become positive signs. -3 times -3 is going to be positive 9. So you'll have to do some careful thinking if that's a mistake you're prone to make. And you notice some things are happening in green and in red. We have the y-intercept again in red in this function. So when it gets graphed onto the graph paper, onto the grid, the x equals 0 value becomes that y-intercept. So there's the 0, 6. Notice what it is in the equation. It's the thing I've underlined in red. And there it is on the graph on the y-axis at 6. Also take a look at the two values that gave us zeros for y, because they're special as well. We call them zeros actually. Okay, and when they get onto the graph, this is where they live in this case. Okay, and then there's something else I can remind you of, and it's way down here. When we did that factoring a minute ago, when you factor this polynomial, this quadratic, there it is up there. We factored it in this screen a minute ago. Okay, when you factor it, excuse all the scanning here, the panning. This can help us find the zeros too. Watch what happens. If we want to find out where y equals 0, we set the whole thing to 0. And then we say, well, what is special about a product equaling 0? There's this thing called the zero product law. The zero product law says when two numbers multiply, or any number of numbers multiply to 0, one of them absolutely has to be 0. You can't get away from it. I could have 1,000. If it multiplies by something to get 0, it has to be that missing number is 0. So we take a look at both of those factors in the following way. Either x plus 3 is 0. In that case, we do a little bit of linear algebra there. Subtracting 3 from both sides, x could be negative 3. Or x plus 2 is 0. In that case, we subtract negative 2 from both sides, and x is, in that case, negative 2. And if we come back here, that's indeed what we got by accident in our table of values. We got negative 3 and negative 2 giving us zeros, which is pretty awesome. We also know from this picture, when we graphed all those points, that we have symmetry. And I've drawn it as a dotted line, my axis of symmetry. I've written it down here, line of symmetry or axis of symmetry, and it's at x equals negative 2.5. Now I know that from just looking, but I know it another way as well. Now these things I'm giving you here are very fast, by the way. You're going to take probably 2 weeks with your teacher to understand the nature of quadratics, but here's just the taste, right? So that line of symmetry is between, exactly halfway between all of those symmetrical points. So the two I took were the negative 2 and the negative 3, and I took the average of them. That's how I can find the midpoint. That's another thing you brought forward with you from grade 10. Negative 3 plus negative 2 divided by 2 is going to be negative 2.5. And then there's one more thing to tell you. If I want to know what the function is, because that little point at the bottom here, this one here, has a very special purpose in lots of the problems that we could study. It's the vertex, or in this case, the minimum point. If I take that negative 2.5 and I put it into the function, I do my computation and I get negative 0.25. I should have negative 0.25 there. I'll put that in right now. So the vertex of this quadratic is negative 2.5 and negative 0.25. That's the point at the very bottom here. And that's your introduction to quadratics. Hopefully I can put a few more things up for you too. This is dedicated to today's student. You know who you are. Bye.